Okay, this is the partial fractions. Not super difficult compared to the things you were doing. And boy, the lighting is so weird. Looks like I have a torch under my face. So the idea of these is simple. You're going to take a fraction that, obviously can't be divided because the top is smaller than the bottom, the power. So the only thing you can do is you can split it up into two different fractions, but you need to solve a system of equations when you do this. Now, the first thing I want to point out, and this is the most important part of the entire question, if you do not factor the bottom correctly, this entire question is over and there is nothing you can do. Now, there's a reason that that question is number one, because even in Calculus 2, I will see students do this to factor that. They see the x squared, they see the minus 4, and they immediately think plus 2, minus 2. And if you did that, it's over. And some students did do that. So it is what it is. What you have to recognize is that there is a common factor, right? So you factor it out. Whoops. It'd help if I could write my 4. So that's the factorization. Now, the goal of partial fractions is to split this up as something over, right? There's two things on the bottom. There's x and there's x minus 4. Your goal is to split the integral up like this, where a and b satisfy this. You need to get an x and a minus 8 on the top of this fraction. So you have to make sure that you get a and b to work out that way. Now, the way that you do it is very simple. Maybe not so simple. You do the crisscross, or as I say in the class, crisscross applesauce. You got a crisscross here. This bottom has to go across and multiply with a. Now I'm going to do it here, and then I'm going to finish it over there because I won't have room. So you're going to do a times x, and then a times minus 4. And you know what? Let me just write that first. You're going to do a times that, and then you're going to do b times x. So when you distribute this carefully, look, you can't, again, when you're doing problems of this complexity, you cannot afford to make simple mistakes. You can't afford to do a times x and then forget to times the a by the 4. You can't factor this wrong. These little mistakes like this just is death on a problem that's more advanced. So now you have this thing, and you're like, okay, what the hell am I supposed to do with this? This thing that you just created, right? You have ax. Now I'm going to combine the ones that go together. You have an ax and a bx, right? You have ax plus bx. Take away 4a. Now, that has to be equal to what was right there. This a and b have to combine in a way that give you x minus 8. So you have a 1x, and then you have a minus 8. Now, it's not that bad. The things that have the x's in them, a plus b, right? There's an equation right there, a plus b. A plus b has to make 1, right? This has an x, this has an x, this has an x. They all have to make the same thing. So the a and the b, when you add them, have to make the 1 that's in front of the x. And now, what's left over? So this is gone, this is gone. What's left over is this. Whatever a is, if I times it by negative 4, I have to get negative 8. I mean, this is a gift that basically, I know what a is now, right? Divide both sides by negative 4. That means that a, right? Negative 8 over negative 4 is going to be positive 2. Careful with your signs. You mess up that sign, the whole thing is screwed. So now I know that a and b have to add up to 1. I also now know that a is 2. I mean, it should be obvious what b is, but, listen, do it all the way out. So I have minus 2, both sides. So that means that b is negative 1. So now if I go back to my original integral, so this is going to be horrible, but the magic of the dry erase board. So, right, I had a plus there originally. Now I know, though, that a has to be 2 and b has to be negative 1. And if you were to combine these, if you were to take these two fractions and make them into 1, right, you would times this by x minus 4. You times this by you times this one by x and get negative x. When you do that, you get x minus 8. So this was the whole point of doing this. Starting with the original integral, you split it off into 2. You figured out those numbers there. Don't worry about this. It's going to take care of itself when I integrate it. Now you just have to integrate these one at a time. But these integrals are always the same. They're always natural log. So this one is going to be 2 ln x. This one is going to be negative 1 ln x minus 4 plus c. Now you might be thinking, do you really need that 1 there? You could just do that instead. Okay? So I'm going to do a couple more examples, and then I'm going to do one that's a little more difficult. But this, I'm going to be running through the exact same thing every time I do them. Okay, here's the second one. Now, on the top this time, you don't have any x's. You just have a number. I'm still going to do the same first step. Actually, I'm going to do this a little bit better than I did last time. First, I'm going to factor the bottom. And again, I can't stress this enough. You cannot factor this wrong. If you factor this wrong, the whole question is, just tanked. So to get a 1 in the middle, you need 4 and 3. And it has to be -4 and +3. That gives you -12 at the end, a -4, right? You can make the rainbow. -4 and +3, make -1 in the middle. So now I'm going to split it up into 2. This time, no, you know what? I think I'll do it the same way I did it. You're going to split it into 2 fractions. You're going to have something over x minus 4 plus something over x plus 3. I want to figure out what a and b are so that I get -21. I'll give you a big super secret hint here. If you ever see that there is no x term, the x's got crossed out, that means that a and b are opposites of each other, but they're the same number. Like 3 and -3, 2 and -2, 8 and -8. The numbers are the same, just they're opposite sign. So you should expect that when I do it. So again, I'm going to do my crisscross. This time I don't want to ruin it. So I'm going to do a times x plus 3. This bottom crisscrosses over to here. This bottom, I'm just going to have to erase it if I do that. So that bottom goes there. That bottom goes there. I finally have my red marker, so I may as well use it. So then I'm going to do x minus 4 times b. Right? So you do the crisscross. So this creates for you an equation with x's and numbers. So you get ax plus 3a, right? Distribute the a. Then you're going to do bx minus 4b. So now I have that whole thing. I have the a. Now I like to put them together. All right. You may not agree with this, but this is what I do. This is supposed to be a plus. It looks like a T. So you have ax plus bx. And then you have a 3a minus a 4b. That whole thing has to be, now I'm going to write this a little differently. That has to be no x's and -21, right? The original question does not have an x in it. So I'm putting a 0 there as a placeholder. I know that whatever a and b are, if I add them together, I get 0. That's the only, right, without an x there. That's the only way that you can get no x, is that when you add a and b, you make 0. That means that a, right, if you do one more leap of logic here, that means that a has to be the negative whatever b is. So I use that. Now, the last part of it is that whatever a and b are, if you do 3a, take away 4b, you're going to get -21. Now, look, you didn't have to do elimination on these. I haven't done one yet where you have to do elimination. But, here, I've been getting lucky. The first example I was able to figure out what a was and just plug it in and figure out b. Here, I know that they're equal except they're opposite sign. So I could go where a is. Now, you have to do this very carefully. I could go where a is and put -b there. So I'm going to replace the a with -b. And again, I cannot stress how important it is. This is not difficult. This is algebra, for crying out loud. It's a linear equation. If you solve this wrong in Calc 2, you have a problem. Cannot make mistakes like this here in this type of problem. So you get -3b minus 4b, right? We'll call them bananas. You ate 3 bananas, you ate 4 bananas, you ate 7 bananas altogether. So then you divide by -7. Notice I'm being very careful. I don't skip any steps. I don't want to make mistakes. So that means b is negative over negative is positive. 21 divided by 7 is 3. So that tells me that b is 3. But I already know that a is equal to the negative of b. So whatever I got for b, I'm going to put it right there. So that means that a had to be -3. So now I could go back over to here, erase my arrows again, model of inefficiency. So a had to be -3, and b had to be 3. Now this tells me how to integrate. Once I know those numbers, that's it. I split apart my original fraction. I factored the bottom. I split it into 2 fractions. The tops are very simple. This is just -3 ln x minus 4 plus 3 ln x plus 3. And yeah, plus c, blah, blah. But we almost don't really care about that anymore. So again, I got, a more complicated thing there, but it was simpler because there was no x there. All right, so that's how to do that one. think I'm going to do 3, and then I'll do one more. Okay, this is number 3. So again, goal is going to be factor the bottom. Always the same. Always the same. Steps are always the same. Back to the bottom. You're going to split it up. You're going to crisscross applesauce. Right? That's a difference of squares. So it's x plus 3, x minus 3. All right? Basic, easy. So let's see. Let's see how this one works out. I'm going to split it up as something over x plus 3 plus something over x minus 3. All right, so then again, I'm going to do the crisscross. I'm going to take the x minus 3 over to the a, and I'm going to take the x plus 3 over to the b. I'm going to multiply it all out, so I get ax. Whoops. Watch the signs. Don't be bad like me. So you're going to do ax minus 3a. Then you're going to do bx plus 3b. All right, multiply it out. Now, that has to be equal to this. So this time I'm not going to bother grouping them together, right? But I am going to reorder them. I have a negative 1x, right? I'm just writing it where the x's first, because I have an x first. And then I have a positive 15, right? How do you know you have a positive 15? Because there's no negative in front of it. So you have a positive 15. That's 15 take away x. It's the same as the thing you started with. So I know that a and b, when I add them together, have to make negative 1 x's, right? You had something with an x, right? This might be 3x take away 4x. Could be 5x take away 6x. But whatever a and b are, they have to make negative 1 when you add them together, right? That's the whole point of this thing. You don't need the x's here, right? They already have the x's. The x's is irrelevant. You're looking at the coefficients, the numbers in the front. So those are gone. So then I know that negative 3a plus 3b have to make a positive 15. Now I have some work to do. So unlike the other two, you got lucky that you were able to determine a and b by using a substitution. Here, that's not going to work. Now, if you were really nuts and you wanted to make the problem harder, you could solve the top equation for a and then plug it here, but I wouldn't do that. This is set up perfectly for you to do elimination. All you have to do, I'm just praying I have enough room here. All you have to do is take the top equation. I have to do this very carefully. I have a 1a and a 1b. I would like to eliminate a, and I'll tell you why I'll eliminate a. Because the signs are opposite. If I just make that 3a, I have a 3a and a minus 3a. I can cross them out. In order to eliminate b, I'd have to times the top equation by minus 3. So remember, you always want to do elimination by addition. Adding is easier. If you do subtraction, you're going to make a sign error. So I always do elimination by addition. So I'm going to do 3 times a, and I'm going to write it underneath the original one. So 3 times a, and then 3 times b. Now be careful, because you have to do everything. You have to times everything by 3, so you get minus 3 there. If you don't multiply everything by 3, you've disrupted the balance. I mean, if I told you that 2 plus 1 was equal to 3, and I multiply this number by 3 and this number by 3, right? Then you have 6 plus 3. That's not equal to 3, right? You have to times everybody by 3 to maintain the truth and the balance of the equality. So I multiply everything by 3, and now look what I got. That's exactly what I wanted. I'm going to add them straight up and down, right? This is called elimination by addition. Minus 3a plus 3a, goodbye. 3 bananas, 6 bananas. Now, if you remember what I said in class, equal sign plus equal sign, bigger equal sign. 15 minus 3 is 12. Now you think, that's so stupid. What am I going to do? This wow, the lighting got so bad. It's crazy. It's like I'm in a... All right, let's see if I can fix this. And I'm not even going to edit it out. What's the point? Let's try to increase the brightness ever so slightly. I mean, it helped a little bit. So you have 6b equals 12. Divide both sides by 6. I know I'm running out of room. That tells me that b is 2. Now you want to go back to the original, only because it's the easier one. You have your original equation was a plus b equals minus 1. Now that I know that b is 2, I got it. Subtract 2. That tells me that a is negative 3. Those are the two numbers that I'm looking for. So I'm going to go back to my original equation and put negative 3 where a was, and I'm going to put 2 where the b was. And then I'm going to integrate it, right? This is so simple to integrate. You just get negative 3 ln x plus 3. And you get positive 2 ln x minus 3 plus c, whatever. So there you go. It's that simple. This one was more complicated because you ended up with a system of equations that you had to solve by elimination. You didn't get lucky. Now I'm going to do one more just for one specific reason. I'm going to jump to number 6 now. This thing will pause. Okay, so this will be the last one I work. Continue to have these lighting issues. It's just time of day. Sun is going across the window, so it's getting darker. Now, this one's a little more complicated to factor. But now you could use the trick that I showed in class, or you could watch one of my other factoring videos and see that trick on, they're called non-monic polynomials. But, you know, look, I'm going to do this real simple. This is very easy to do. There is no choice here. It's not like it's 6x squared, and it could be 6x and x and 3x and 2x. This problem is very simple, and you should just do exactly what I'm going to do. I know that it's 2x and x. I know this for a fact. There's nothing else that's going to multiply to be 2x squared. Now, the question is, with the 3. Look, the 3 either goes here and the 1 goes there, or the 3 goes here and the 1 goes there. Now, just try it. I know that the signs have to be different. How do I know that? Because I know I have a negative at the end. So I know one of them is plus and one of them is minus. Now, I'm just going to try it. I'm going to see how it comes out. Here you would have a plus 3. Here you would have a minus 2. That's not going to work, right? A 3 take away 2 is not 5. So I have to switch it then. I'm going to put the 1 here. Now look, if it didn't work, let me show you that it won't work, and then I'll adjust it. Let's say I put the minus here and the plus here. So now I would try that. I'd get plus 1. And over here I'd have 2 times negative 3, which is minus 6. You're like, oh man, I just missed. I have negative 6 plus 1. That's negative 5. Very easy to fix. Just make this one plus, make this one minus. And now you got it. In the middle, you have negative 1x, and at the end, you have a positive 6x. 6 take away 1 is the 5. 1 times 3 is 3, and you already know that 2x and x make 2x squared. So that's the fast way to factor that, right? So it had to be 2x and x. I needed the 3 here, and I needed it to be positive to make a positive 6, and I needed a negative 1 here, right? Because you needed positive 6 take away 1. Right, so it's not hard to factor. Don't go crazy factoring this. Be like, oh, I'm going to do grouping and this. You don't need to do any of that. It's overly complicated. So now again, I'm going to split it up. I want to take a over 2x minus 1, and then I need b over x plus 3. Right? It's whatever you got here. You split it apart into 2 different fractions. Don't forget your dx. Okay, so I get to this point. I do my crisscross. And I'm going to do it here. So you're going to get a times x plus 3. And you're going to do, right? I don't want to draw the lines because that's risky. And then you're going to get b times 2x minus 1. This is the first time I had something other than an x. I have a number in front of it, so it's going to change the problem a little bit. Now that has to be equal to ax plus 3. Now I just did this and I accidentally wrote 13. And then I got all the way down to the end and it didn't work. And I didn't realize why. You got to be very careful. I wrote a 13, and it screwed up the whole thing on the end. All I did was just copy it wrong. So you have to be really careful. So I'm actually redoing this. I already did it. A times x plus 3 times a, right? Distribute the a. Now distribute the b. I have to be very careful here. This is 2bx, right? There's a 2 there. And then you have minus b. And that has to be 8x plus 3. Like I said, I wrote a 13. It screwed the whole problem up. Now, the things that have x's have to go together, right? The numbers in front of the x's have to create x. Have to create 8x. So whatever a and b are, if you take a and then you add it to 2b, you have to make 8, right? The things in front of the coefficients of x have to match. So then I can cross those out. I don't need them anymore. So now this is where I'm going to use red. So that means that what's left over, right? The things that don't have x's have to make each other. So that means that 3a minus 1b have to make 3, right? These numbers have to make 3 or you don't match the original thing. So now, when I'm doing this, I want to eliminate b. If I just put a 2 here, I have positive 2b minus 2b, I cross them out. To eliminate a, I'd have to multiply the top by negative 3. And I'd rather not have to multiply by a negative because it's easier to make a mistake. So what I'm going to do, I'm going to multiply the entire bottom by 2 so that I can cross out the b's by elimination. All right, now again, be careful. My parentheses are not here. My parentheses are here. So what you are really doing is timesing each of these dudes by 2. And if you want to be really careful and paranoid, you can do that. I'm going to double everybody on the bottom. I'm going to leave the top exactly the way that it was. Everybody on the bottom gets doubled. So then I'm going to have 6a minus 2b, which is exactly what I want, and then 3 times 2, which is 6. Now I see it's going to work. It didn't work when I screwed it up. I wrote a 13 here, and I ended up with a 26, and the problem was over because I screwed it up. And keep my arrow there. So now, be careful here. 1 apple and 6 apples is 7 apples. If you do something dumbass like write apple squared, the problem is over. 2b minus 2b, yay, they're gone, they cross out. That's the whole point of doing elimination. Get rid of one of the letters. Equal sign, bigger equal sign. 8 and 6 make 14. Thank God it works this time. Divide by 7. Helps tremendously when you write the correct numbers down. Divide 14 by 7, you get 2. Yay! That's what A is. So now I'm going to go back. I always like to go back to, one of the equations is always more complicated than the other one. I happen to think that this equation is a little more basic. So I'm going to go back and put 2 here and solve for B. So then I'm going to subtract 2 from both sides. That means that 2 bananas equals 6, right? 8 minus 2. So divide both sides by 2. So you get B is 3. Now I'm going to go back. Now this was by design. This is exactly what I wanted. This is how I create the question on my test. So B was 3, A was 2. Right? I didn't get any negatives this time. Now, when you integrate this is the whole thing. If you were to take the derivative of ln 2x minus 1, right? Remember that this is your u. It would be u on the bottom, right? It's du over u, and the derivative on the top. So I have a 2 there already. So this fools people. Some people will just say, oh, it's 2 ln 2x minus 1, but it's not. If you were to take this derivative, you get that. This 2 is not needed. So there's no 2 there. This first one, when you integrate it, is just ln 2x minus 1. That is exactly why I have this 2 there. That is already the derivative of the bottom. Du over u. So it's ln u. So you don't need anything. You don't put a 2 in the front. You don't put a half in the front. You just put nothing. There's a 1 there. And that one, though, right, there's a 1 here. So the 3 has to go this time. That's going to be 3 ln x plus 3. This is why I chose to do this example. But this right here. Because I know the one that I create on the test works out just like that. Just like that. It might not be that. It might be 3 over 3x minus 1. But it's the same thing. This is the derivative of that. The derivative of 3x is 3. So this would just be ln 3x minus 1 if you were to integrate it. Right? So this is what I do on a question like that. That's exactly why I did that example. And look, these are kind of they're not super long. They're a little bit of a pain in the neck. So, I mean, I already did 4 of them, so I don't want to do any more of them. But, this is always the gist. But this is where you have to be very, very careful. Watch your signs. I screwed it up because I wrote a 13 instead of a 3. It's edited out. You'll never see it. But this is what I did. I made an error. I copied it wrong. Instead of writing a 3, I wrote a 13. And I only noticed at the end because I got, I had like 7a equals like 30. And I was like, what? It doesn't, if you don't get whole numbers on these, I will always rig them. Whole numbers, positive or negative whole numbers. If you get some crazy ass fraction, you did it wrong. All right. So again, as always, hope this is helpful.